For tonight's homework, students are going to work on a skill that we used yesterday in class, and today they're going to be able to either create tape diagrams. I like to also do the equivalent fractions. So in the first couple, you'll see the related denominators. So what that means is I see 4 and I see 8. And when I see 4 and I see 8, I know that 4 can become 8. So that's what makes them related. This mixed number can just stay the same, and the only one I have to make a change to is 2 3/4. Because this is 2 3/4, and it's compared to 2 7/8, there's actually, I can ignore the whole number because if I think of the number line, they're at equivalent places. So I want to ask myself how I get from 4 to 8 using multiplication. Students have practiced this in class, so they should recognize that 4 times 2. They need to do the same multiplication on the top so that they're multiplying by a fraction equivalent to 1 whole, which is 2 over 2. They can see they get 6/8. So this 2 3/4 is actually comparable, it's equivalent to 2 6/8. So when we do that, we can see that 2 7/8 is larger. So on part B, they're going to want to change 1/3 to some number of 6 using that same method of multiplying by a number here, the same number in the numerator so that they're creating an equivalence. In C, they're going to want to change 1/4 into some number of 8s. And in D, they're going to do 2 steps. The first step is going to be take out the whole number. So how they're thinking here, how many 3/3 are there in 21/3? That's going to help them determine how many whole there are. And then that number itself should actually help the student be able to determine greater than, less than, or equal to. For this one, for the area model, we see that we have unrelated denominators. So what that means is 5 can't be changed into 4 and 4 can't be changed into 5. Unlike at the top, if they're related, one could be changed into the other, like 4 could be changed into 8. So for these, the method that we use is we think of both denominators as factors of some number. What can they both become? What do they both are a factor of? So sometimes kids can, multiply to find that, but the easiest way is to multiply them by each other. So in this case, 5 times 4 is 20, meaning we need to turn 4/5 into some number of 20ths. You're going to do the same thing here, but first, again, students are going to think about taking out the whole number. How many sets or copies of 4/4 can I take out? So skip counting to determine that and seeing what fraction of fourths is left. Once they know that number of fourths, they're going to turn it into some number of 20ths. That way they can compare them. And so on B, you can do the same practice. 5 and 3 are unrelated, but multiplied together, 3/5 can become some number of 15ths, and 2/3 can also become some number of 15ths. So multiplying to find the equivalent fractions and then substituting them back in. So being able to say what this is and what this is, and then being able to compare them. When we have a common denominator, like here, when we have 15, we're talking about equal sized parts. So the number in the numerator that's greater, the more parts we have, the greater the fraction's value. And then on the back, students can use any strategy. Mostly they can use multiplication. On the front it said use an area model and tape diagrams. If students can just do it mathematically, that's fine. If they prefer to have the support of an area model or a tape diagram, they're welcome to do that. And again here, also to support students, this half is going to become some number of 8. So finding an equivalence, 5/6 would become some number of 12ths, and so on.